Algebra 2, this is Unit 2, Lesson 5, writing quadratic equations in 3 forms. And this is page 7 of your packet. So today we're going to talk about converting between the 3 forms we learned about in Lesson 1. So going from vertex to standard, factor to standard, standard to factor. So we're going to do the first 2 pages on the video, and then you're going to do the group practice and the independent practice on your own. Try your best, okay? And if you have any questions, please email me. So let's get started. So going from vertex form to standard form, that looks like this. We'll go from vertex form, which is y equals ax minus h squared plus k, to the form, so this is vertex, to y equals ax squared plus bx plus c. So let's actually do an example. Let's use the problem y equals 2x minus 3 squared minus 1 as an example. So this is in vertex form, and we're going to go to standard form. And remember, at any point, just pause and write everything down. Also, there is an answer key online posted. So step 1 is to expand. I'm going to rewrite this. Y equals 2, x minus 3, x minus 3, minus 1. There was a squared here, so I wrote the parentheses twice. There are 2 factors. Then you're going to multiply these. There are a lot of ways you can multiply these. There are a lot of strategies. A lot of you are familiar with the area model. A lot of you like to FOIL. You could do either. I'll just show you right here. I will be teaching both methods in this class. Do whichever one you like best. So x times x is x squared, negative 3x, positive 9. When you combine those like terms, you get x squared minus 6x plus 9. So I'll rewrite that over here. Y equals 2, x squared minus 6x plus 9 minus 1. I'm going to distribute the 2 and combine like terms. So y equals 2x squared minus 12x plus 18 minus 1. Our final answer is y equals, we'll just combine this 18 and negative 1, 2x squared minus 12x plus 17. Oh, I think in the original, on the key, I wrote plus 1. So let's make this a plus 1. And that's actually going to be 19. Sorry, guys. Okay. Let's go from factored form to standard form. So factored form looks like this. I know the letters are intimidating. Don't worry about it. It's just the formalities. This is standard form. So yesterday or the last lesson, we were graphing in all 3 forms. Now we are like converting between all 3 forms. So let's use, this as an example. Let's do y equals 2, x minus 1, x plus 3. So now you're going to do exactly what we did here and then multiply by 2. Looking at my key, I made a mistake on this, so I'm going to actually re-upload a new key tonight. I'll do that. So I'll use the FOIL method here because I used the area model in the last one. So you'll do x times x, which is x squared. You're going to distribute twice. X times 3, which is 3x. Negative 1 times x, which is negative x. Negative 1 times 3, which is negative 3. Y equals 2x squared plus 2x minus 3. Combining like terms, our final step is to distribute 2x squared plus 4x minus 6. And that's it. Okay. Going from standard form to factored form, we're going to factor. So going from y equals ax squared plus bx plus c to y equals dx plus or minus e, fx plus or minus g. So we're going to factor. This won't work every time because factoring, you can't factor everything, but if I ask, I'll make sure it's factorable. So let's start with this. And we are going to really go over factoring in a few lessons, but here's a quick review. So with factoring, it's a times c that adds to b. So we're trying to multiply to 9 and add to -6. Which is going to be -3 and -3. This is an Algebra 1 skill, but we're bringing it back. So you can use the area model, or you can use factoring by grouping. Whichever one you like better, it doesn't matter. I'm going to teach you both ways eventually. Let's use the area model for now. And you factor the sides. Okay, what's the common factor here? X. I can take out an X from both of these. What can I take out here? An X. What times X is -3? -3. What times X is -3? So our factored form is just this. Okay, so what conversions are we missing here? We're missing standard form. To vertex form, which we will learn in lesson 3 by completing the square. Okay, so we're going to write these in all 3 forms. Vertex form is the fastest, especially from a graph. So all we need is the a value in the vertex. So my a value, I find that because I went over 1, down 1 to get to this point. So a equals -1. And then my vertex is 2, 4. And now you have all the materials to plug it in. Okay, so now from that, we're going to use what we did above. So now from vertex form to standard, that's this. So we get y equals -1, x minus 2, x minus 2 plus 4. I'm going to distribute the x and the -2 to all the pieces. Y equals -1, x squared, x times x. X times -2 is -2x. -2 times x is -2x plus 4, and that plus 4 is still on the end. Fix this. So you get y equals -1, x squared, combined like terms, minus 4x plus 4 plus 4. When I distribute the -1 to everything, we get y equals -x squared plus 4x minus 4 plus 4. So our final answer is y equals -x squared plus 4x. That's our standard form. So I'll put boxes around my answers. Factored form, I'm just going to factor this. And you might think, well, what can I factor out? Well, they both have x's. I like to factor out my negative from the front. I like my a value to be positive. -x, x minus 4. And that's our factored form. That's it. So I just took all of the examples we did up here, and I used this graph to get it to vertex form, and then I was able to convert using all the steps we did above. This is another way we can ask these questions with like small word problems. So it says, write the equations of the following quadratics. Unless I specify the type of form I want, you can write it however you want. Has a vertex at -3, 5 and an a value of -3. So with the ingredients given, an a value and a vertex, I would say that vertex form is the fastest. Y equals -3, x plus 3 squared plus 5. Done. Okay, has x intercepts at -3 and 5 at an a value of 1? Which form utilizes intercepts? Oh, that's factored form. So I need to work backwards here. So if my answer was x equals 3, sorry, -3, what factor did that come from? Well, I know it looks like this. Oh, well, it must have been x plus 3, because if I minus 3 on both sides, I get -3. Oh, this must have been x is -5, x minus 5, sorry, and an a value of 1. So y equals x plus 3, x minus 5. You don't even need to put that 1 in there. It's because it's assumed. Okay. Write an equation in standard form, so we're being specific, that has a vertex at 1, -5, and an a value of 2. Can I go right to standard form? What needs to happen first? I can't go right to standard form because standard form doesn't include the vertex in the a value. It has an a value, which will be 2, but it looks very different. From what they're giving me, I can go right to vertex. So we're going to go vertex, then to standard. So working with what we got, y equals 2, x minus 1 squared minus 5. If they didn't specify the form, we'd be done, but they did. So now I'm going to expand that. Okay, I'm going to use the area model here. I told you I would show you both forms. Or you could FOIL, you got the same answer. So we get, when we combine like terms, this becomes -2x, -x minus x. I'll continue my work up here. Y equals 2, that 2 is still there. X squared minus 2x plus 1 minus 5. Once again, this -2x is because of this -x minus x when I combine my like terms. I'm going to distribute the 2 and combine like terms. I'm almost done. I have one more step. And that's the answer. Okay, start on the group practice and the independent practice. If you have any questions, write them down, talk to a friend, email me, okay? Bye guys, good luck.